Okay, so we have Unit 2, Notes 8, Angle Proofs. Okay, so in this first page, it's just definitions, postulates, theorems that you'll use. And these are like tools in your handbag to figure out problems and figure out why things are the way they are. So if we have, and to use them to prove other things, okay? So maybe we use this definition of congruence, so we can start using that for substitution. We use this for definition of angle bisector, so we get an equation, right? We can get two angles equaling each other, or those two angles equal both of them. 2 times one of those angles equals the whole thing. All those kind of things. Complementary, all these things will start helping us getting these equations and everything we need, substitution, transitive property, to be able to prove whatever we need to prove. Okay. So one of the most important things with these is being able to recognize what you're seeing, okay? Because sometimes the statements will be given, and then you'll need to be able to recognize what happened there, okay? So some of these are filled out already. Definition of a right angle, we know, is 90 degrees, right angle. If x is supplementary to y and x is supplementary to z, then y is congruent to z. So that is congruent supplementary theorem. All right, so in this one, if x is supplementary to y and x is supplementary to z, then y and z are the same. So watch. So if x is, let's say x is, I don't know, 50 degrees, okay? Y would have to be 130 for it to be supplementary. Then x again is 50, and if z is supplementary, then it also has to be 130. Okay, it's kind of a form of transitive property. All right, so vertical angle theorems, we've gone over across from 2 straight lines. Angles across from 2 straight lines, looks just like that. Definition of the complementary angles. Also, if you notice, you can check out vertical angles. For vertical angles, if you get 2 pins, you'll notice these 2 angles are congruent, these 2 angles are congruent. It doesn't matter how you angle the pins, these 2 are going to be like the same looking angle, and these 2 look the same. That's how vertical angles work. It's pretty cool. All right. If M and N form a right angle, then M and N are complementary. Okay? That is complement theorem. If M and N form a right angle, then M and N are complementary. Just saying a right angle is 90 degrees, so if 2 angles form that right angle, then they're complementary. They're 90 degrees. Definition of perpendicular is number 6. Definition of perpendicular. Okay, given, so if line L is perpendicular, this is the perpendicular sign right here, to M, then angle 1 is a right angle. And that's just telling us that when we have 2 lines like this, if we have a perpendicular line right here, it means it forms a right angle on this. So it's perfectly straight up on this, okay? If L is, if W and X are supplementary, then W and X equals 180. That's just supplementary angles. If L is complementary to M and N is complementary to M, then L is congruent to N, and that's the congruent complement theorem. So just like congruent supplement theorem, but this one's complementary angles. If N and P are complementary, then N and P equal 90 degrees. That's just definition of complementary angles. And, with these definitions, they just said, well, They made it up, right? They said this word, complementary, and you could Google where complementary comes from if you're interested. And they said, okay, this word means these two angles add up to 90 degrees. All right, angle addition postulate. This one for 11, okay? Just saying these two angles add up to the whole thing. Just like segment addition. It's telling us this line's not taking any degrees. If this is 30 degrees, this is 60 degrees, then the whole thing is 90. If this is 30, this is 70, then this whole thing is 100, okay? And then the last one, definition of congruence, we've gone over a lot, okay? All right, so let's get into the proofs. So some of them are filled out for you. If you have any questions on those, as always, just email me. PQR is a right angle. We're always starting with a given, okay? Now let's look at it. We're trying to get to PQS and SQR are complementary. PQS and SQR are complementary, okay? So we're given these statements right here as well, okay? PQR, we're not given them, but it's not given like, it's just, we're given these statements like the writer of this worksheet showed us this, the statements, and then you're just giving the reasons. But we could figure this, if they didn't give us these statements, we could still figure this out, okay? So PQR is a right angle. PQR is 90 degrees. That's definition of a right angle. It's just telling us if two angles, or if an angle equals 90 degrees, then it's a right angle. PQS plus SQR equals PQR, okay? These two angles add up to the whole thing. That's angle addition postulate. PQS plus SQR equals 90 degrees, okay? So what happened here is, if PQR equals 90, PQS plus SQR equals PQR, then PQS plus SQR equals 90, and that's transitive property. You're always thinking with transitive property, and I told you it comes up a lot. A equals B. C equals B. Therefore, C equals B. Okay? Maybe it would help. A equals B. C equals B. Therefore, I'm sorry, not B. C equals A. Therefore, C equals B. C equals B. Okay? It's transitive property. All right. Then lastly, we have PQS and SQR are complementary. That's just definition of complementary angles. If two angles equal 90, add up to equal 90, then they are complementary angles. We know that by the definition. Okay? So if you're looking at this and you're trying to figure out how would I do this without being given the statements, what they're doing is, well, first they're working off what's given. Okay, once they're given this right angle, okay, we can know that they're 90 degrees. And we know it's complementary, so we're going to have to get to 90 eventually. Okay, then we're trying to get some kind of equation so we can use substitution or transitive property. Okay, so the equation, angle addition postulate's a great one to do an equation. Okay, or angle bisector. All right, so if you notice, a lot of these just have equations and then you're substituting things, okay? This one has, yeah, so this one is pretty straightforward, so email me if you have any issues with that, okay? So this one, we have 1 and 2 form a right angle. That is given, okay? Now, if you notice, this part's also given, but it's not in the second part, so it's gonna come later. It actually comes here. Prove 2 and 3 are congruent. 2 and 3 are congruent. So we can't look at this and say, well, they look the same. So based on what's given, we should be able to find it and to look at this. Okay? If they are form a right angle, then they are complementary. Okay? That's complement theorem, which is something new. Okay? Complement theorem says if two angles form a right angle, then they are complementary. Okay, doesn't work the reverse. We don't know if two angles are complementary. We don't know if they form a right angle. Okay, they could be away from each other, non-adjacent. All right, then we have 1 and 3 are 90 degrees. That's given. 1 and 3 are complementary. Okay, that is a definition of complementary angles. So when you're trying to figure this out, look at the difference between complement theorem and definition of complementary angles, okay? And then once you look at the difference and you see the differences, it'll help you understand complement theorem a little bit better, okay? Now we have angle 2 and 3 are congruent. Now this is something we just learned in the beginning part of this. This is congruent complements theorem. Congruent complements theorem. This is just saying if 1 and 2 are complementary and 1 and 3 are complementary, then 2 and 3 are complementary. It's kind of as a form of transitive property. So if we said 1, let's give these arbitrary numbers. Let's say 1 is 30, 2 is 60. 1 needs to keep being 30. We said it's 30. So 3 would also have to be 60. Therefore, 2 and 3 would be congruent. Okay, that's how that works. Okay, now let's go to 5. All right, this is a bit longer. We're given that RSU is congruent to VST. RSU, this one, and this one are congruent. Now we need to prove that RSV, this whole thing right here, these two angles, is congruent to UST. These two angles, okay? All right, so first one, we know that they're equal. So this is just a definition of congruence. All right, RSU. So definition of congruence, why do we use that? Well, we're using it because we're saying they're equal. Now we can substitute this thing, okay? We can substitute each of these. Now let's get an equation, okay? So RSU plus USV is equal to RSV. So it's just saying these two angles add up to the whole thing. That is angle addition postulate. Okay. Now we're saying VST and USV is equal to the whole thing. Again, angle addition postulate. Okay, now we're going to use substitution right here. Okay, so now that we have these two equations, we can substitute VS, or let's see which one they use, okay? All right, so what they did was they kept this whole equation, but then they substitute RSV and UST. No, they didn't. Okay, so they take this whole equation and they substituted RSU for VST, and then USV they kept the same. So just this one right here. This and this right here, okay? So this went into this and turned out to this, okay? That's substitution. All right, and I usually do RSU equals VST. And then you don't have to do this part. You can just put substitution. That's fine. Okay. Then we know this is called, this is transitive property. If RSU plus USV equals RSV, and Oh, okay. Then RSV. So we'll put transitive property here. All right, so we know that, so we have these two equations right here. RST, or VST plus USV equals UST. RSU plus USV equals UST. Okay, so we're looking at these two right here. So these two for transitive property. This one and this one, okay? So these two things are equal, are the same right here. And they both equal, and then they both equal this and this. Therefore, both of these. So if you put A equals B, C equals, oh no, this is A. A equals C, therefore B equals C. B equals C, okay? And you don't need to write these things right here. I'm just illustrating for you if you need that extra help with it, okay? And then lastly, we have RSV equals UST, and that's just definition of congruence. Okay, these are tricky. You just keep working at them, and you'll start understanding the logic of them. All right, 1 and 2 are complementary. That's given. 3 and 4 are complementary. That's given. Okay, I'm going to go a little bit quicker through these because this video is going a little bit long. Definition of complementary angles. Definition of complementary angles. Because it says they're complementary, so they're just, now we can make them into equations. 2 is congruent to 3. Why are these two congruent to each other? Vertical angle theorem. This one comes up a lot. It's nice because it doesn't need to be given. We just know those two are vertical angles, therefore they are congruent to each other. Then this one is just definition of congruence. We did that so we can use this for substitution or transitive property. All right. Then we have here, this is transitive property, okay? One and 2 equal 90, 3 and 4 equal 90, therefore 1 and 2 and 3 and 4 are congruent to each other. This equals this, okay? Then we can substitute here. This is substitution. And what we're doing is 2 and 3 we're substituting in. So 2 is substituted with 3, and that's it. So it's just this 3 is going right into here, and it's coming out to this, okay? Then 1 and 4. So what happens is we subtract measure 3 from both sides. So that's subtraction property of equality. And you could put PE there if you like. And then just definition of congruence. I feel like this is kind of unnecessary because we know that they're equal, so therefore they're congruent. However, it's just showing us that every single step needs a reason, needs a specific reason, okay? All right, so now we're gonna get into some actual statements. And I'll try to go a little bit quicker on these last ones. So we're given on here, and then 2, okay, so if 1 and 4 are congruent, therefore angle 1 is equal to angle 4. Then it says we're given, so let's find the given that hasn't been given yet. We did 1 and 4 already, so it's angle 4 and angle 5 form a linear pair. All right, 4 and 5 are supplementary, okay? That's something we haven't worked too much with. That's called supplement theorem. And use that front page if you get stuck on these, if you practice these on your own. So we have supplement theorem right here. If 2 angles form a linear pair, then they are supplementary, okay? We can't go backwards with that. If 2 angles are supplementary, we don't know if they're a linear pair, okay? Unless we can see it. So then we have definition of supplementary angles. So that would be angle, why would we use that? We want to get an equation so we can use a little substitution. Equals 180. If they're supplementary, then they add up to 180. Then we have substitution. So what can we substitute? Angle 1 into angle 4, okay? So measure of angle 1 plus measure angle 5 equals 180. And then we'll do here angle 1 equals angle 4, just to illustrate that point. And then angle 1 and 5 are supplementary. That's just definition of supplementary angles. And that's because if 1 and 5 add up to 180, then they are supplementary, okay? All right, last one. All right, so we have, this one is given, okay? All right, A and B and C are perpendicular, and we're trying to get to 1 and 2. 1 and 2 are congruent. A and B are perpendicular, okay? ABC is a right angle then. ABC, this one. So if AB and BC are perpendicular, if this is perpendicular, we just draw a line out here, it means this angle right here is a right angle, okay? And that is definition of perpendicular. That's what it tells us. 3, if we have definition of a right angle, that means these two angles, angle 1 and 3, are going to add up to 90. But we're not going to do that yet. We're not going to do that yet. So all we're doing with this one is just saying ABC equals 90 degrees. And it seems a little redundant, but it's telling us we can't say 90 degrees yet unless we have definition of right angle. Then measure 1 plus measure 3 equals ABC. That is angle addition postulate. It's just telling us these two angles add up to the whole thing. Okay, then we're going to say ABC equals 90, 1 and 3 equals ABC, therefore 1 and 3 equals 90. That's transitive property. And then we have this one, definition of complementary angles. That's the reason for it, okay? So what that's saying is 1 and 3 are complementary because they add up to 90. We're just going to say angle 3 are comp. Okay, then we have a given. It's right here. Angle 2 and angle 3 are complementary. Okay, if 1 and 3 are complementary, 2 and 3 are complementary, therefore 1 is congruent to 2. All right, that is congruence complement theorem. All right, hopefully you enjoyed that. Hopefully you enjoy the logic of these things, how they all add up to one thing and they all have a specific reason for everything they do, okay?